Hello, and welcome to Module 2. This is Cloud Concepts. You're going to see throughout this course that I generally like to kick things off with a quote from somebody who's relevant to what we're talking about, or relevant in the industry. The reason why I do this is it kind of gives us a good way to make it relative to something that we do, or maybe even people that we know. In this case, Steve Jobs, we pretty much all should know who he was. And he had a very interesting quote where he said that, "I don't need a hard disk in my computer if I can get to the server faster. Carrying around these non-connected computers is Byzantine by comparison." And what Steve Jobs was talking about with this is that traditional computing and the way that it was being done just didn't make sense to him, nor did it make sense to most people in the industry. He had a real vision for how cloud computing and centralization and using mobile platforms and other ways to access information was going to be directional. He had a great mind for direction, and a lot of other great folks in the industry have the same mind and the same ideas. And that's why OpenStack is such an important thing. But before we go diving into OpenStack and what it is, let's go and talk about the very basics, and let's review what cloud computing is versus virtualization. Now, when I say versus, I don't mean this as in one versus the other in a argumentative or adversarial way. I mean just in a comparative sense. I'm assuming that you've got a good sense of general, what we now call traditional virtualization, and we're going to take some of those concepts and show how they map up in the cloud computing environment. When we go even further back, before virtualization, we had what we know now as traditional server deployments. I would ask for an application, or somebody in my business area would ask for an application, and I would deploy a server for it. If I wanted to be able to have a development environment for that server, we'd deploy another server. In fact, we'd usually then deploy one for disaster recovery, just because that seemed like a good idea. By the way, that is a great idea. But you can see the pattern that's building here. Whenever we wanted to have a new application, typically we would put it on its own server. So what ends up happening is this massive expansion, and these were not even rack and stack as we talk about, but these were tower computers, and they would sit on shelves in large data centers. There was a real inefficiency going on, but it was completely natural for us to think this way and work this way, because that was all that was available at the time. We started to move into more tightly managed blade environments, and we were starting to see more converged servers. More computing and networking power was being put into smaller spaces. We were using rack-mounted servers. So now, when we wanted to spin up a large number of servers, even at one application, one server, using that one-to-one mapping, it was a lot easier for us to get greater density using these new blade and rack server environments. But again, we reached a point where even that was becoming inefficient. And then along came virtualization. So traditional virtualization, as we know it, was where we took all of these servers that we had, and rather than just deploying endpoint operating systems to run applications, we would do something different. On top of this, we would run hypervisors. So the hypervisor would run at the bottom layer directly above the hardware. And we could use different hypervisors, including vSphere or KVM or Xen. Hyper-V as well is one that's come into real popularity more recently. And this layer allowed us to virtualize the hardware and treat it as a pool of compute power. Then what would happen was our consumer of our service, we talk about our business consumer usually, and this doesn't necessarily have to be a customer, it could be somebody in our own department. They would make a request to the IT department. That's folks like us. So that request would come in saying, I need some kind of an application area. In the previous world, we'd have to deploy a physical server, we'd have to order it and wait for it. Now, all we had to do was make a request into our virtualization platform and just spin up a virtual instance. In fact, if they wanted that development environment for it, no problem. They want a UAT environment, no problem. They wanted a disaster recovery environment, no problem. They wanted to scale it out by another node. No problem. We'd effectively loosened up the requirements for us to be hardware-based, and we shortened the time to market for our consumer in order to get where they needed to get. This is a great advancement, but we needed to do something even better. This is where cloud comes in. Now, cloud in itself is a very broad term, and there's a lot of different definitions, but I usually use 3 criteria when I'm describing it. A cloud is on demand. It's elastic, and it's self-service. These are key requirements. What the on-demand means is that it has to be available as needed, immediately, or at least with some sense of immediacy. It's not something that you have to put in a request and it gets emailed to somebody, and then they take care of it and then get back to you whenever they get a chance to. It has to be elastic. By elastic, we mean both kinds of elastic. Not just traditional outward growth, but in fact, we need to be able to grow it and shrink it on demand. And it needed to be self-service. Self-service, again, is very important. This is the ability to allow our consumer to make the request directly. You might even find that the IT department is the consumer of the service through that self-service panel. But regardless of how we deal with it, it has to be done through a self-service panel, not requiring you to go and physically deploy something or programmatically, build something and create it through a number of clicks and drags. It needed to be something that should be available from a service catalog. In your typical on-premises computing service stack, wow, sorry, that's a lot of words. But let's just take a look at what a service stack looks like. A traditional on-premises environment is what we have today in most places. There's a networking layer, a storage layer, server layer, so that's that physical server layer. Above that, we had the hypervisor, the virtualization layer. The operating system that's now a guest operating system, which is going to service the endpoint. Middleware environments, and this included message queuing and other services. A runtime environment, say it was a Java environment or a PHP environment or Cloud Foundry. There's a lot of different programming and runtime environments. The data layer, and then finally the actual application layer where the application code runs. This all together makes the traditional on-premises data center management model. So right now, this entire stack is managed by our IT department. And if you're the consumer of that service as a business user, you rely entirely on your IT department to manage all of this platform from end to end for you. There's no participation by the end consumer in this process. Now, before we go any further, we've got one quick tip. On-premises is just what it sounds like. It means on your premises. We also call it on-prem for short. And the reason for this is we never, ever say on-premise. It's not that on-premise isn't a word or a phrase, but it actually is not the one that we're going for. So you'll always see us say on-premises or on-prem. Occasionally an on-premise slips through, but we just have to watch out for that.